Jitters Coffee makes two types of cookies, M&M and Reese's Pieces. One batch of M&M cookies uses 5 cups of sugar and 3 cups of flour. One batch of Reese's Pieces cookies uses 2 cups of sugar and 3 cups of flour. The shop has 180 cups of sugar and 135 cups of flour available. Jitters wants to maximize profit from its cookie sales. One batch of M&M cookies yields a profit of $40. One batch of Reese's Pieces cookies yields a profit of $30. Find how many batches of each cookie type the coffee shop should bake. So I'm going to start off with identifying what my objective is, and it's finding how much or how many batches of each cookie type the coffee shop should bake. And right here, this overall objective helps us define the variables because it says find how many batches of each cookie type, and that is what's missing. I'm going to identify my variable x as number of batches of M&M cookies. I'm going to identify my variable y as number of batches of Reese's Pieces cookies. After identifying my x and y variables, I'm going to write my objective function because my objective function will take care of the overall objective, but also use our variables. So I'm going to highlight where I'm finding my objective values from. And because it says that Jitters wants to maximize its profit, and it tells you that M&M cookies make a profit of 40 and Reese's Pieces make a profit of 30, we're going to use that information right there to indicate that the total profit will be $40 times each batch of M&M cookies, represented with the variable x, plus $30 times each batch of Reese's Pieces cookies, represented with the variable y. So this here is my objective function. Besides from my objective function, I have some other constraints that I need to write, and the constraints consist of the other totals that we have. So as I look at this description, as I look at the overall problem, I know that I have a few other totals involved. So I can see that I'm dealing with sugar, and we have a total of 180 cups of sugar. And I'm also dealing with flour, of which we have 135 cups of flour. So I'm going to highlight everything to do with sugar in pink. And what I notice about sugar is that M&M cookies uses 5 cups of sugar, and Reese's Pieces cookies uses 2 cups of sugar. What I notice about flour is that M&M cookies use 3 cups of flour. Reese's Pieces also use 3 cups of flour. So right here, what I looked for, I was looking for totals. And those totals helped me write my constraints. Again, my totals were sugar and flour. Those were the only 2 totals I had within this problem. To write my constraint for the total of sugar, we use 5 cups of sugar per batch of M&M cookies, so 5x, plus 2 cups of sugar per batch of Reese's Pieces cookies, plus 2y. And we have a total of 180 cups of sugar. So our left side can add up to anything equal to or less than 180 cups of sugar. For flour, each batch of M&M cookies uses 3. Each batch of Reese's Pieces uses 3. We have a total of 135. This side can add up to be 135 or less. It just cannot be more. Besides from our totals, and our totals again were sugar and flour, we also have to make sure we define our variables. So our variables are M&M cookies and batches of Reese's Pieces cookies. But no matter what, you have to make sure you make at least, or you have to make 0 or more. So no batches, which would be 0, or more than 0 batches. But you cannot make a negative number of batches of cookies. So you have to make sure you indicate that both your x and y variable have to be greater than or equal to 0. If they're equal to 0, that just means you make 0 batches of that flavor cookie. So here is your objective function and your constraints. You have to graph these, and then you have to optimize the problem, which means you have to identify your vertices and substitute them into the objective function, solve and find which situation would yield jitters the most amount of profit. So I'm just going to graph this function without saying anything. I think graphing is something we've been working on for a while, so I'm sure the difficulties here were more writing the problem than they were graphing. So for the rest of this problem, just pay attention to the video. I'll explain my answer at the end, but in the meantime, just pay attention to how I graph. Now that we've graphed and we found our vertices, we can make a table and evaluate all of our vertices with the objective function. We have a vertex at 0, 0, a vertex at 36, 0. We had to find the point at 30, 15. I used elimination for that. And lastly, we have a vertex at 0, 45. We are evaluating these in the objective function, which we wrote at the beginning, of 40x plus 30y. And I'm just going to use my calculator to evaluate these quickly. So the first value would be p is equal to 0, 40 times 0 plus 30 times 0. The next vertex would be evaluated at 1,440. The next vertex of 30, 15 would be evaluated at 1,650. And lastly, the vertex of 0, 45 would be evaluated at 1,350. So our maximum profit is $1,650. If I was to write a complete sentence to answer this, I would say something along the lines of Jitters would make a maximum profit of $1,650 if they make 30 batches of M&M cookies and 15 batches of Reese's Pieces.